Hello everyone, welcome back to my channel. It's me Abhay speaking. So today we are going to the second part of basic mathematics, which is calculus. As you might have known by now, we have finished the first part of basic mathematics, which included basic 2D geometry, 3D geometry, trigonometry and logarithm and some basics of first year and second year physics. So today we are going to discuss the most important part, which is calculus. This calculus part is very important and will be used in many of the problems in first and second year. But anyways, you learn this in detail in second year. So I will teach only the physics part. Okay, how much hour is required for physics, I will be teaching that much. So calculus comprises of two parts, which is differentiation and then integration. Okay, what are those and how do you use? Are there any formulas? What are those formulas? All those things I will be discussing in this chapter. Clear? Okay, let us go to the next part. So first part is differentiation. Okay, what is differentiation? Let us check. Okay, as you can see, I have a funnel over here. I will change the color of the pen. Now what I will do is I will add some amount of water. When I add some amount of water, as you can see, or as you can imagine, the speed of water at this part and the speed of water at this part, speed of water at this part will all be different, will all be varying. Even if you take this part and this part, the speed of water will be changed. If I take this part and even the next part, the speed of water is changing. So what is exactly happening over here is speed is varying. Speed is varying. Now, because the speed is varying, if I ask you to find a speed of water at certain point, how will you do? You will use the help of differentiation. Clear? Okay. Now, how is it represented by? See, differentiation of a function with respect to x is represented as d by dx. Differentiation of a function with respect to y is d by dy. With respect to y, d by dz is what? Differentiation of a function with respect to z. D by dk, differentiation of a function with respect to k. Okay, d by dp, differentiation of a function with respect to p. Is it clear? Okay, now let us see the formulas used in differentiation chapter. What are those? First, here I have kept all the list of formulas which you will need. Okay, so let us actually go one by one. First is what? Differentiation of x power n is n times x power n minus 1. Differentiation of sine is cos. Differentiation of cos is minus sine. Differentiation of tan is secant square. Differentiation of cot minus cosecant square. Differentiation of e power x is e power x. Differentiation of log base e, log of x base e is 1 by x. Log of x base e is nothing but what? Ln x. Okay, now this is the differentiation of a power x is what? A power x into ln x. Is it clear? I will write two more formulas. Okay, copy it down. Differentiation of sine inverse x is what? 1 by root 1 minus x square. Okay, differentiation of cos inverse, if you take, is the same but with minus sign. 1 by root 1 minus x square minus 1 by root 1 minus 1 minus x square. Differentiation of tan inverse is what? 1 by 1 plus x square. Okay, note it down. Next, I'll go to the next part now. Now we'll solve some questions. Okay, yeah, I forgot one more thing. Yeah, differentiation of a constant is nothing but 0. Okay, keep it in mind. Next, differentiation for like f of x plus g of x. Basically you can write it as differentiation. Okay, of course bracket is there, can individually differentiate them. Okay, now if you have some constant, if you want to differentiate a constant times a function, what you will do, you'll just take the constant out, then you will differentiate that function. Is it clear? Fine. Now another important part. Okay, just a second. Yeah, another important part, differentiation of f of x into g of x is not equal to differentiation of f of x into differentiation of g of x. Okay, keep it in mind. Clear? Now I will also let you know one more notation which we use quite often in differentiation chapter. Okay, which is if we have differentiation of f of x, instead of writing df of x by dx, we just write it as f dash of x. If you again differentiate, what we'll write? If you further differentiate, we will write it as f double dash. So let us solve some basic questions. Clear? You can pause the video and try these questions. Now let us start. Now first let's differentiate 2 times x to the power 5. How do you do? We'll write it first. dx of x to the power 5. 2 times x to the power 5. So what I will do, I will take 2 outside constant. What I will do, d by dx of x to the power 5. Now d by dx of x to the power 5. What is differentiation of x to the power n? What you will do basically is, listen, remember this trick. Bring this n below and reduce 1 from the power. This is the trick. Okay, now bring 5. So what is it? 2 times, we'll differentiate this, which is what? 5 times x to the power 5 minus 1, which is what? 10 times x to the power 4. Clear? Done. One more question. Try this. Differentiation of 9 by x to the power 7. Now what we'll do is, listen carefully. I want to differentiate 9 by x to the power 7. Okay, I will bring 9 outside. What I will do is, I will bring 9 outside. 9 times differentiation of x to the power 1 by x to the power 7, which I can write it as x to the power what? Minus 7. Now what is it? Same. What is it? 9 times minus 7. I bought the 7 outside, into x to the power minus 7 minus 1, which is 9 times minus 7 times x to the power minus 8, which is what? Minus 63 x power minus 8. Clear? Note it down. We go to the next question now. UV rule or product rule. What is this? Now, do you remember I told you before, d by dx of f of x into g of x is not d of f of x into d of g of x. So what is the formula for this? We will see. What I will be using is, I will write d by dx of f of x. as f dash of x and d by dx of g of x as g dash of x. Okay. Now, what is it? What I will do is take any one function. I will take the first function, differentiate that. Okay, so differentiated. But second one you keep it like that only. Multiply, but don't differentiate. Now add a plus symbol. Now what you will do? Take second function, which is the remaining one, differentiate that, and multiply it to the first function. So this is called product rule. Clear? Clear? Now you can do it in any way you want. Okay, so next we'll see u by v rule. What is u by v rule? Assume you have a function which is of x by y for. How do you differentiate that? For that you have a formula. So we'll see what that formula is now. So basically it is what? D by dx of f of x by g of x is what? Listen to me carefully. I have not pre-written this formula on the screen because I want to make sure you remember in the class itself. Okay, listen. What we'll do first, we'll take the numerator function and we will differentiate that f dash of x. Okay, now what I will do, same, multiply with the other function, same as uv rule, but here you will have a minus sign because u by v. Okay, then what we can do, take differentiate g of x, then what we will do, multiply it with the first function. This is not it. Now what we will do, divide it by what? Denominator ka whole square. So this is the formula. Clear? Now in case you don't want to remember this formula, what else you can do? However, I prefer you to remember this formula. But in case you don't want to remember, we can do one thing. What we can do is, you want to differentiate f of x by g of x. I'll keep f of x as it is. And g of x, I will write it as g of x ki power minus 1. Okay, what I'll do it as g of x ki power minus 1. Then what I'll do, you can differentiate. Clear? Then use what? UV rule. But what do I prefer? Remember this formula also. Okay, so shall we solve some questions? Pause the video and try the questions. Try to solve them. You can solve them. Okay, try it. First one we'll try. First is what? Based on UV rule. Now, what is it? Take this as f of x. Take this as g of x. What did I tell? First, differentiate the first function. Keep the second one as it is. Differentiate the second. Keep the first one as it is. Okay. Now, what is the first function? E of x. Now, differentiate e power x. What is e power x ka differentiation? E ki power x. Differentiate. Sorry, keep sign as it is. Second function, what is its sign? Keep sign as it is. Now, listen to me carefully. What I will do, I will differentiate the second function. Differentiation of sign, cos. What I will do, keep the first function as it is. That's it. If you want to simplify, you can take e power x outside. You can write it as sin x plus cos x. Okay, this is the answer. Now second question you can try Try it on your own. It is what? X by cos x plus 9. Let us solve now. This question is based on u by v rule. Okay, try it. What I'll do, this is f of x, this is g of x. Okay, use u by v rule. Okay, don't use a second method because you don't know something called chain rule. So use u by v rule now. First, what I'll do, I will take the first function as it is, or I'll differentiate the first function. Differentiate. So differentiate the numerator. Differentiation of x is 1. You know what? I'll write the formula. Wait. Just a second. I'll write the formula. Yeah. See, what is it? I will differentiate the first function. Keep the second function as it is. Minus. Differentiate the second function. Keep the first function as it is. Whole divided by second function whole square. Clear? Now, this is the formula now. Now, we'll solve. Differentiate the first function, which is what? 1. Keep the second function as it is. Cos of x plus 9. Okay. Minus. Okay, what you will do? First function as it is. No, second function you differentiate. Now the thing is, you want to differentiate cos of x plus 9. How will you differentiate? First, this is what? Differentiation of f of x plus differentiation of g of x. I mean differentiation of f of x plus g of x is equal to differentiation of f of x plus differentiation of g of x. Differentiate them individually. Differentiation of cos of x minus sin of x. Differentiation of 9, which is a constant. Differentiation of a constant, 0. So what are you getting? Minus sin x. Okay. Is it over? No. By denominator square. Clear? That's it. Simple question. Done. Next. Chain rule. Now, what is chain rule? Listen to me carefully. There are some functions like, if you want to differentiate, let us say sin 8x. Okay, e power tan x. Now, what is the problem in this? E power x differentiation you know, but e power tan x you don't know. Sin of x differentiation you know, but you don't know sin of 8x ka differentiation. So, in order to be able to differentiate these type of functions, there is a rule called as chain rule. Okay, what is that chain rule? We'll understand. Now, there are two ways of understanding chain rule. I will tell both the methods. Listen to me carefully. I will explain with the help of an example. Let us say you want to differentiate sin 2x. Most common example. Let us say you want to differentiate sin of 2x. How do you differentiate this? Now, first you know differentiation of sin x, but you don't know differentiation of sin 2x. Okay, let us do one thing. Let's do what you know. Differentiate sin. Assume 2x as x. You can assume. For now, assume, no? Of course, 2x you can't take it as x. For now, you think 2x is x. Differentiation of sin x is cos x. But here we write 2x. Okay. Now, then what happened? 2x you assume it as x na. Differentiate 2x. What is it? 2. I write it here. So what is it? 2 cos 2x. One more rule. There it is also called as bicycle rule. How do you do? Again, I'll take the same function. Okay. I will take another color this time. Now, what we'll do? You start from here. What did you see? You saw sin x only. So you differentiated. What is it? Differentiation of sin 2x. Cos 2x you wrote. But now what happened when you came here? You saw 2x. What did you do? You differentiated it. What did you get? Okay, you can understand using any of the methods. Okay, we'll solve some questions. Pause the video and try it. First question: differentiate log of tan x. It is log base e, or you can take it as ln. Okay, I'll write it as ln. Okay, in order to avoid confusion, let us differentiate ln of tan x. How do you differentiate? I will use bicycle rule. So first I saw ln of tan x. Okay, first when I saw from here, I only saw what I started from here. I saw ln of x. Differentiation of ln of x, 1 by x. Now what did I do? I came here. I saw tan. Now what I am doing? I am differentiating tan of x. Differentiation of tan, secant square. So this is the answer, but you can further simplify. Listen to this simplification process. Okay, this is very important. What I will do, secant square I can write it as 1 by cos square. I'll write it as c. Tan you can write it as sin by cos. 1 cos gone. What did I get now? 1 by sin x into cos x. What I'll do, I'll multiply and divide it by 2. Where did I get that idea? 2 sin x cos x. Do you remember a formula? Yes. 2 by sin 2x. So 2 by sin 2x can be written as 2 cosecant. This is the answer. Clear? We'll do second question. E power cos of 2x. Start from here. E power x ka differentiation. E power x. Keep it like that. E power, you wrote it as cos 2x. Now what did you do? You came here. Cos 2x you saw. Cos x you saw. Differentiation of cos minus sine. Here what is that? 2x. Right? 2x. Now what did you do? You came here. This part. You saw 2x. Differentiate 2x, which is 2. So what are you getting? Minus 2 sin 2x into e की power cos 2x. Clear? Done. Here are some more questions. Cos of 21x. Okay, you can actually do this on your own. It is similar to sin 2x1. Now here is a quick trick. Okay, you call it as a trick or whatever you want, formula, whatever you want. I prefer you to remember this. Differentiation of cos of nx, sin of nx. What is it? What you want to do is just differentiate this function. Listen, differentiate this function and whatever number is there, this is only for x power 1. Whatever number is there beside it, put it as 20, multiply it. So it is what? 21 cos 21x. Okay. Then now here x square is there. You can't use that trick. What we'll do? We'll use chain rule. We'll start from here. What did you see? Tan. Differentiation of tan, secant square or 9x square. Okay. Now what did you do? You came here. You saw 9x square. Differentiate 9x square, which is 9 into differentiate 9x square. What do you do? Tell me. Use the formula, which is what? 9 times 2 times x ke power 2 minus 1. So it is basically what? 18x into secant square 9x square. Clear? Okay. Now I have a bonus question for you. Okay. Pause the video, give it a good try, because this contains all the concepts we discussed till now. What all concepts does it have? It has what? U by V rule. Okay. Then what is there? You have chain rule and formulas also. Most of the formulas are included. Not most. Like you can see e power x, you have tan x square, and you have differentiation of x bar n also. So okay, try this. Give this question a good try. I hope all of you have paused the video and given it a good try. Now we will solve this question. Okay, listen to me carefully. How we will go? First, this is what u by v. First, we'll start calmly, and first, what we'll do, we will differentiate the first function, which is log of 7x plus 3. Differentiation of ln, this is base e. So, differentiation of ln of x is nothing but what? This part, which is what, beta? 7x plus 3. 1 by x. Differentiation of ln x is what? 1 by x. Now, okay, you started from here. Now you came here. You saw 7x plus 3. Differentiate 7x plus 3. 3 to gone na, differentiation of 7x plus 3. If you want, you can try. What is it? You differentiated this, which is 7 into x ki power 1 minus 1 x ki power 0 plus differentiation of 3 0. So basically it is what? 7. Now what you are doing, multiply it with the denominator. What is it? E power tan of x. E power tan x square. Now what I will do? I will include minus. Now what we are doing? We will keep the first function as it is. Now we will differentiate e power tan x square. Okay. This I will differentiate in the side and I will show you. Because here you have to use chain rule 2 times. Okay. See. I will use some other color so that you can understand. Okay. See. We will differentiate e power tan x square. Now, what we'll do, we are starting from this point. What do you see? Only e power x. Whatever it is, you saw e power x something, don't care about anything, differentiate that. Okay. Now what you will see, you came from here, you came to this point. You saw what? Tan. Differentiation of tan, secant square. Now from this point you came to this differentiation of x power n. What did I tell? Bring that down, decrease it by 1. So I write it directly. 2 minus 1, 1 x. So what is it? 2x e ki power tan x square into secant square x square x square. Clear? I'll write it there. Two x into e ki power tan x square into secant square x square. Most people leave it here. What do you have to do? By denominator का whole square e power tan of x square का whole square. Basically, should I write this 2 over here? E ki power 2 whole square is nothing but e ki power 2 into 2, which is e ki power 4. Nah, correct, nah. What should I write? Should I directly write it over here? Yeah, tell me if it is okay. Done. That's it. See, bonus question is also done. This is the most difficult differentiation they can give you in physics. Okay, we'll go for next. Next part is maxima and minima. See, this part again we learn it in second year, but you require it in many chapters of physics. So I'll teach you how much ever is required for physics. Okay. Now, what is maxima and minima, and how do you find out the maxima and minima of a given function? Now, let me give you a graph of a function. Okay. Assume a graph of a function is like this. Okay, something like this, and I say, where is the minima, or what is the minimum value of this function? What will tell? Hey sir, it's so simple, it's this part. You will tell, okay, very simple. Then I'll tell, okay, you do one thing, tell me the maximum value. You will tell, sir, that's even simpler, this part. This part, okay. I will tell, where does the maxima occur? I will tell, here. Okay, I'll ask, where does the minima occur? You will tell, here. Okay, it is quite simple if I give the graph. But what if I tell you, you can find out the exact maximum and minimum value of a function without plotting graph? Aren't you shocked? That's what we are going to learn. That's the beauty of mathematics. Okay, so we'll learn how to do. Assume you have a function f of x. Okay, wait. Yeah. Assume you have a function f of x. If you are watching this video, I hope all of you know the basic and you know what is a function. Okay. If you don't know, go learn it and then come watch this video. Okay. Now assume you have a function f of x. Now you want to find the maximum value of that function. So basically what you are going to do, step 1, whatever the function is, it doesn't matter. Okay, whether it's a linear, whether it's a quadratic, it is cubic, it is 4th degree, 5th degree, it doesn't matter. What you will do, you will differentiate the function. If you want to find the maxima and minima, what you will do, differentiate. Okay, doesn't matter if you want to find maxima or minima, just differentiate. Okay, if you have even sine, cos, tan, log, even e power x, anything you have, don't worry, just differentiate that function. Now we'll go for step 2. Put f dash of x is equal to 0. Okay, what you will do, we'll put f dash of x, is equal to 0. Here you will get some values of x. Of course, it will have some roots. Yeah, so you will get x is equal to some values. Now, at these points, either maxima will occur or minima will occur. But what will occur at what point? How do you know? That's what step 3 is. Step 3, what you are going to do is, listen carefully. You will double differentiate the function. Now, if f dash, then you will put that value over here. Assume we got the roots as 2, 3. You will find f dash of 2. You will find f double dash of 3. You will put. Now, if f double dash of x is positive, there are 3 cases. Equal to 0, we will not discuss. Okay. If f double dash of x is greater than 0, what does it mean? Minima. At that point, minima occurs. Lesser than 0, which means maximum. Okay? Clear? I'll write it neatly. Step 1. What is it? Again recap. Find f dash of x. Step 2. Put f dash of x is equal to 0. Step 3. What are you going to do? Here we will get some root. Find f double dash of x. Now, if f double dash of x, okay, what if f double dash of x is 0? No maxima or no minima, and no minima at that point. If f double dash of x is, what is it called? Inflection point. Okay, inflection point. You learn it in class 12th. Not required. If f double dash of x is greater than 0, there is minima at that point. Okay, if f double dash of x is lesser than 0, there is maxima at that point. Clear? Now, we will solve a question. Find the maxima and minima of the following function. Now, what did I tell? Whatever function you find, it doesn't matter, differentiate it first. Okay. Differentiate this plus differentiation of this plus differentiation of this. So differentiation of x square is 2x. Differentiation of 5x is what? 5. Okay, you found out f double dash of x. Now what is the next step? F dash of x 0. Okay, I put it 0. Now what is it? X is equal to minus of 5 by 2. Okay, x is equal to minus 5 by 2. Now, is there a maxima or minima at minus 5 by 2? We don't know. Okay, let us find out. What we'll do is, we'll differentiate this again. Again, if we differentiate, what are we getting? 2 times of 1 plus 0, which is 2, which is what? Positive, which means there is what? Minima at that point. What is the minimum value? Put x is equal to minus 5 by 2, which is what? Minus 5 by 2 whole square. I mean, put minus, what we have to do? Put x is equal to minus 5 by 2 in the given question. So what is it? Minus 5 by 2 whole square plus 5 times of minus 5 by 2 plus 9. Okay, whatever value you get, that's the minimum value. Okay, now this process of finding is fine. Okay, it's fine, proper only. Now what you could have done instead of double differentiating it, here is the idea. Protecting it is of the form y is equal to x square plus something. Okay, this is what? A parabola. How is the parabola? Coefficient of x square is positive, so it is a upward parabola. So in an upward parabola, what exists? Minima. At this point, minima. Is there a maxima? No, maxima is at infinity. Directly could have told. Clear? Try this question now. Pause the video, try this. Okay, differentiate this. What are you getting now? Tell me. 3x square, 12x plus 9. Understood? Clear? Again, just use the formula. It's like combination of all the previous basic problems. Okay? Similar. Now, what I told, f dash of x 0. Understanding now? I'm going little fast on this problem. You have to be this fast. Actually, you have to be even faster than this. Okay? Now, what is it? Take 3 common outside. All these things you have to do in mind. Okay? Throw this 3 that side. Now, what do you have? You have this. Find out the roots. What are the roots today? Tell fast. Plus 3, plus 1. Plus 3 and plus 1 are the roots. Okay. What we'll do? Tell me. Double differentiate this. What is it? 2x plus 4. Now what you can do, put plus 3 and plus 1. Okay, something is interesting. Both you need not find the exact value. If you put plus 3 or plus 1, whatever it is, don't you think you are getting a positive value? What does that mean? Okay, there is only minima. There is only minimum. Minima exists at both plus 3 and plus 1. Okay? No maximum. Clear? For a given function, it's not necessary that it has only minima. Okay? Or for a given function, it's not necessary that it has only maxima. Okay? For a given function, it is not necessary it has either maxima or minima. Okay? Or for a function, it is not necessary that it has both maxima and minima. I hope you have understood. It can be any of the cases. Clear? So two of the questions which I have taken have coincidentally turned out to have only minima. Okay. Now, here is a bonus question for you. Okay. I want you to try this as homework. Okay. So that's it with differentiation chapter, and the next part of calculus, which is integration, will be dealt in the next video, as this has already become about 40 minutes long, and all the top quality questions which I told in the beginning will be there in integration chapter at the end. So make sure you watch the second video and try out those good quality questions. If you have any doubts, let me know in the comments down below. So until then, see you. Bye bye.